Okay, welcome. Good morning. We're going to be working right now on the 2017 multiple choice part A of the Calculus BC practice exam. For this part, we are not allowed to use a calculator, so everything we do has got to be by hand. Okay, question number 1. We want to find the derivative of f of x. And looking at the question right here, we are going to have to use the chain rule a couple of times. So the derivative is 2 times cosine of 3x minus 5 times the derivative of cosine times the derivative of 3x minus 5. When we clean this all up, we are going to get 6 cosine of 3x minus 5 times sine of 3x minus 5. And that is, oh, you know what? I missed a negative right here with the derivative of cosine. There we go. D. Number 2, the integral of this function. Now, when you integrate, there's a lot of advanced techniques we can use. But with this problem, the best thing to do is to simplify before we integrate. So using the in and out rule, we can convert the radical t into t to the power of 1/2. Then we can multiply the t's, giving us t to the power of 3/2. Then we can bring the t to the top, to the numerator, by making the exponent into a negative. And now it's a simple integration problem. We add 1 to the exponent, and we divide by the new exponent. Okay. Dividing by negative 1/2 is the same thing as multiplying by negative 2. So the answer right here is A. Okay. Number 3. Find the derivative. Nothing too complicated here, just a simple quotient rule. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay. Now it's just a matter of cleaning it up carefully so we don't make any mistakes. So negative x cubed minus 2 minus 15x squared minus 3x cubed okay, distribute the negative 15x squared plus 3x to the power of 3. The bottom doesn't change. And last but not least, combine like terms. So we have 2x cubed minus 15x squared minus 2 all over the bottom squared. Let's see. That is C. The position of a particle moving in the xy plane is given by this vector. Y is a twice differentiable function. That sounds important. At t is equal to 1/2, what is the acceleration vector? Okay. Well, if we're given the position vector, to find the acceleration vector, all we got to do is take the second derivative. So my velocity vector is 12t squared. Now, when you derive the y component, make sure that you use the chain rule. So we have y prime of 2t times 2. Now take your second derivative. This gives us 24t, comma, y double prime of 2t times 2 because we have to use the chain rule again. Okay. Next, we're going to plug in the 1/2 we were given. That gives us 12, comma, 4 y double prime of 1. And that is B. No. Oh no, what am I doing? That was D. There we go. Really careful when looking at your answer choices. Okay, number 5. To what number does a series converge? Okay, when we did series, we normally used the summation notation with an n, but it can change, right? Right here we see a k. So k is the variable. K is the value that's changing. This right here is a geometric series because we have a common ratio. Every time that we're getting the next term, we're multiplying by a negative v over pi. So that's the common ratio, negative v over pi. So to figure out what it converges to, we're going to use the formula arc divided by 1 minus the common ratio. So we have negative e over pi to the power of 0. That's where the series starts. 1 minus negative e over pi. This becomes 1 over, okay, we're going to get a common denominator for the 1. So it becomes pi over pi. This allows us to combine the fractions into pi plus e over pi, and finally multiply by the reciprocal. And the answer is C. Number 6. We have the graph of f of x. Which of the following is true? Okay. Okay, so the first option is talking about the derivative. It's the definition of a derivative. And this is saying the derivative as you approach a exists. And if you look at the graph, we have a removal of a discontinuity, which means the derivative does not exist. So false. The limit as you approach a from the right side is not the same as the left side, but that's actually false since both of them are approaching the same value, right? The removal of discontinuity. C, the limit as x approaches a of f of x does not equal f of a. That one's actually true. The limit is whatever y value this graph is approaching, right? Whatever this y value is. But f of a is wherever the point is defined, which is down here. So that's true. And just to be sure, we're going to go ahead and check D. The limit as x approaches a does not exist. Well, we know the limit exists. This is actually false. Even though we have a removal with discontinuity, the limit does exist. They're getting closer and closer to the same y value. Number 7. Given two integrals, find the integral from negative 10 to 6 of g of x dx. Okay, this is what I'm going to do. I'm going to take the first integral and I'm going to flip it. Negative integral from negative 10 to 4 of g of x dx plus the integral from 4 to 6 of g of x dx. These two integrals create the integral from negative 10 to 6 because this limit of integration matches this limit of integration. So now just take the values. Negative 3 plus 5 equals 8. That's your answer. Oh, number 8 is already created, so I guess I'll just talk about it. That's probably because somebody asked me during class about number 8. The length of the curve for sine of 3x from 0 to pi over 6 is given by, okay, well, first of all, you have to know your formula for arc length, which is the integral from a to b of the square root of 1 plus f prime of x squared dx. If you know your formula for the arc length, this question is pretty easy because all you got to do is find the derivative of f of x, which is 3 cosine of 3x. That's all you got to do. Select your answer, which is D. Number 9. The slope of the tangent line to the graph at x equals ln of 2 is which of the following? Okay. Let's take our derivative while doing our product rule. So the first times the derivative of the second plus the second times the derivative of the first. Plug in your ln of 2. Okay, simplify. E with the natural log, they cancel each other out. So that leaves us with a 2. And if you look at your choices, it looks like it's option B. That is the slope of the tension line. Okay. Number 10. F of x is the solution to the differential equation with the initial condition that f of 2 is 8. What's the approximation for f of 3 using Euler's method? Using 2 steps. Okay. Euler's method is all about creating tangent lines. Okay. So we learned it by making a table where we take all of our information and we just organize it. So the first x value is given to me by the initial condition, which is 2 and 8. That's my point. Next, I'm going to find my slope. dy dx is equal to x minus y, so 2 minus 8 equals negative 6. That's your slope. Okay, now I can make my tangent line. Y equals negative 6, x minus x1 plus y1. And using my tangent line, we're going to find the next y value. See, our goal is to get all the way to 3. And because we're using 2 steps, my next x value is going to be 2.5. And then after that, we're going to get 3. So that's the ultimate goal, right? Figuring out the y value at 3. So if I use 2.5, here I get negative 6 times 2.5 minus 2 plus 8. Y equals negative 6 times 0.5 plus 8. Y equals negative 3 plus 8, which is 5. Okay. Now with my new point, I have to find my new slope. dy dx is x minus y, which is negative 2.5. Make your new tangent line. Y equals m, x minus x1, plus y1. And now we use the next x value, which is 3. So y equals, since all the answers are in fractions, I'm going to take my tangent line and I'm going to start changing my decimals back into fractions. So negative 2.5 is negative 5 over 2. Plug in your 3. Minus 2.5. Hi, I posted it on the wall. Thank you. Okay. Y equals negative 5 over 2 times 0.5, which is 1/2, plus, well, the 5 is going to become 20 over 4. I see, I'm thinking ahead because looking at your tangent line, once I multiply my two fractions, I'm going to get negative 5 over 4, which is why I had a common denominator of 4. This becomes 15 over 4. C. (11) Find the derivative at the point 2, 1. Okay, easy stuff. Just take our derivative using implicit differentiation. So my derivative is 2x plus, okay, for the next piece, we're going to use the product rule and implicit differentiation. So it's the first times the derivative of the second plus the second times the derivative of the first. Okay. The derivative of 3y is 3y prime, and the derivative of 3 is 0. I should cross this off because it looks confusing. Okay. Since we're given a point to find the slope, you don't even have to isolate y prime. You know, we can plug in the numbers already. So this is 2 times 2 plus 2y prime plus 1 times 1, which is 1, minus 3y prime. So if we combine like terms, we're going to get negative y prime, 4 plus 1, that's 5. Add the y prime to the other side, and we get that the slope is 5. Number 12. Okay, this is an advanced integration technique right here. Taking a look at the integral, you can't do u substitution, you can't do integration by parts. We don't even know an antiderivative for this. So again, when we're gonna be doing partial fractions. So when you're dealing with partial fractions, the first thing you want to do is you factor out the denominator, and that's going to become x minus 3 times x minus 1. This allows us to take the current integral and separate it into several fractions, right? Depending on how many pieces we have in the denominator. So we're going to have a over x minus 3 plus b over x minus 1. And if I had more pieces, I would continue creating the pieces, just continuing the letters using a, b, c, d, and so on. Okay. Now, to be able to do this integral, we have to figure out what a and b are. So I'm going to take my original integral and make it equal to my two fractions, a over x minus 3 plus b over x minus 1. Oh, and you know what? Why don't we factor out the denominator again? X minus 3 times x minus 1. So what you want to do right here is basically solve for a and b. We're going to multiply both sides by the denominator to cancel it out. And same thing over here. We're going to multiply by x minus 3 times x minus 1. And we're going to distribute. What ends up happening is that the x minus 3's cancel for the first fraction, leaving us with a times x minus 1. And for the second fraction, the x minus 1's cancel, which is b x minus 3. Now from here, we're going to solve for a and b by plugging in our zeros, which I did not solve for yet, but they're pretty easy to figure out. My zeros happen when you set x minus 3 is equal to 0 and x minus 1 is equal to 0. So my zeros are 3 and 1. Yeah. So what happens when you plug in x equals 3? Well, we're going to get 9 plus 1 is equal to a times 2 plus b times 0. This becomes a 10 is equal to 2a, which means a is equal to 5. Now we're going to repeat the process by using the other 0, x is equal to 1. So that means we have 3 plus 1 is equal to a times 0 plus b times negative 2. So 4 is equal to negative 2b. Thus, b is equal to negative 2. Okay. With these values, we can go back to the integral and say that we're going to be integrating 5 over x minus 3 plus negative 2 over x minus 1. And now it's a simple antiderivative. We have 5 ln of x minus 3 minus 2 ln of x minus 1 plus c. Okay, too much. Number 13. Which of the slope field is the slope field for the differential equation? Okay, well, right off the bat, I can already eliminate a and c, because if you look at your differential equation, x squared and y squared are going to be positive. Always positive. It doesn't matter if you plug in a negative x or a negative y, the square will get rid of it. And if you look at A and C, all of those have negative slopes, right? You can't have that. You can't have negative slopes. Okay. Now it's between B and D. And look at this right here for D. Look at all those lines right here. We have a slope of 0, right? So they're saying whenever x is equal to 0, the slope is 0. But that's not true. Take a random point, for example, 0, 5, and you plug it into your differential equation. dy dx is equal to 0 squared plus 5 squared, which is 25. So we're supposed to have a slope of 25, and we don't. They're all zeros. So it's not D, and it's B. Okay, number 14. Find the derivative. But we're not actually looking for the derivative. We're just trying to set it up using the definition. And the definition of the derivative is the limit as h approaches 0 of f of x plus h minus f of x over h. And if you know your definition, you can automatically cross off b and d because they'll say the limit as x approaches 0. Okay. Now the next thing you need to know is that you're going to take the x plus h and you're going to plug it into f, right? We're not multiplying f by x times h. We're substituting it in. So that would be 3x plus h squared plus 2 times x plus h minus f of x, which is, you know, your 3x squared plus 2x. But this is already enough for me to select my answer. My answer is C. Oh, another question that you guys already asked me in class. Number 15. So we're just going to talk about my work right here. Okay, which of the following statements is false? So it says the limit as x approaches 1 for f of x is 0. If you look at your graph, the limit is in fact 0, so that's true. B, the limit as x approaches 2 for g of x does not exist. That is also true, because the left-hand limit is 1 and the right-hand limit is negative 1. So they're correct. It doesn't exist. C and D. Okay. So the answer is C, as you can see by my work. So C and D are a little bit tricky, and to be able to answer this correctly, we have to remember that the right-hand limit must equal the left-hand limit, which is what I'm doing right here. So if I take the limit as x approaches 1 for f of x from the right side, you can see that it's 0. And if you take the limit as x approaches 1 from the right side for g of x plus 1, it's basically saying g of 2, because we're approaching 1, and 1 plus 1 is 2. So that right there is negative 1. So 0 times negative 1 is 0. Now do it again for the left side. The limit as x approaches 1 from the left for g of x is also 0. Here, follow this arrow. 0. And the limit as x approaches 1 from the left for g of x plus 1. So we're doing g of 2, but from the left side, which is 1. But 0 times 1 is 0. And this shows us that the left-hand limit and the right-hand limit equal each other. Now, if you do the same process for D, you're going to see that this right here is true. So once again, C is the answer because they're saying the limit doesn't exist, but I got 0 equals 0, which is true, right? The limit does exist. The limit exists. Okay. 16. Which of the following is the interval of convergence for the following series? Well, if you want to find an interval of convergence, we're going to have to run the ratio test. So we're going to say the limit as n approaches infinity of the absolute value of a of n plus 1 divided by a of n Oops. Now let's practice the notation, because even though we don't have to show work on the multiple choice, it's crucial in the FRQs. So we have the limit as n approaches infinity of x plus 2 to the power of n plus 1 divided by 2 to the power of n plus 1 times 2 to the power of n, x plus 2 to the power of n. The limit as n approaches infinity. Okay. This one will cancel with this one, and this one will cancel with this one. But we still have pieces remaining, right? We still have the absolute value of x plus 2 to the power of 1. I didn't cancel the power of 1 divided by 2. And because we no longer need the limit notation, we can take that off, and we can take off the absolute value. We can say x plus 2 divided by 2 is less than 1. And if I take off the absolute value, we're going to say that it's also greater than negative 1. So solve for x. Negative 2 is less than x plus 2, which is less than 2. Negative 4 is less than x, which is less than 0. Okay. That means C and D are not the answer. And look at A and B. The only thing that's different is that negative 4 is actually included in the solution. So we don't have to check both negative 4 and 0. We're just going to check the negative 4. So the question is, does the series of negative 4 plus 2 to the power of n divided by 2 to the power of n converge or diverge? Well, that is negative 2 to the power of n divided by 2 to the power of n, which you can technically factor out the n. Negative 2 over 2 to the power of n, which is negative 1 to the power of n. This series diverges. This series diverges because if you start getting the terms of this series, we're going to have negative 1 to the power of 0 plus negative 1 to the power of 1 plus negative 1 to the power of 2 plus negative 1 to the power of 3, and so on. That's going to give us 1 minus 1 plus 1 minus 1 plus 1 minus 1, dot, dot, dot. So our series is never approaching a certain value. It's going from 1 to 0 to 1 to 0 to 1 to 0, right? Because we're actually adding these values. So it diverges. So negative 4 is not included. The answer is A. Oh, you know what? I'll put a little note here. Ratio test. And if you need more examples, you can check out the homework where we talked about interval of convergence. I don't have to write that. It's right here. Okay, the integral from 0 to 5 looks complicated, but just like in the previous problem, if you simplify the integral, then it's no longer that complicated. We can just solve this by doing a simple u substitution. I'm going to let u be 1 minus 1/5 x. So when I take my derivative, I get negative 1/5 dx, or in other words, negative 5 du equals dx. And you know what? I'm also going to change my limits of integration. U of 5 equals 1 minus 1/5 times 5, which is, oh, it's no good. Where did my work go? Oh man, this took me all the way to the bottom. Sorry. This is where I'm at. Okay, so this was 0, and u of 0 is 1 minus 1/5 times 0, which is 1. So my new limits of integration become 1 and 0. Careful when you put them back. The square root of u times negative 5 du. I'm going to take out the negative 5. But when I flip my limits of integration, that negative becomes a positive. So now we can just integrate it by adding 1 to the exponent and dividing by the new exponent, or multiplying by the reciprocal. Oh, we don't need a plus c. Integrated from 0 to 1. So this becomes 10/3, and we're going to plug in the 1. The 1 to the power of 3 halves minus 0 to the power of 3 halves, which is just simply 10/3. Okay, number 18. Which of the following limits are equal to negative 1? Okay. Well, for number 1, we need to know what the graph of the absolute value of x over x looks like. When you start plugging in numbers, let's say you plug in 1, 2, 3, or 4, because you're taking x divided by x, that just gives you 1, right? So we're going to have an open circle, and it's constantly 1. You're dividing x by x. But when you plug in negative x values, we get, for example, the absolute value of negative 2 over 2 over negative 2, which is 2 over negative 2, which is negative 1. So we're constantly getting a negative 1. The limit as you approach 0 from the left is negative 1. Check. So C is gone, because that one doesn't even have a 1. And number 2. For number 2, let's see, can we factor it? Two numbers that multiply to 12 and add up to negative 7, x minus 3 times x minus 4. For the denominator, we're going to factor out a negative, x minus 3. If you cancel these out, we get negative x minus 4. And if we take the limit as x approaches 3, we get negative 1, which is positive 1. So no. So that means D is gone. It contains 2, but it didn't work out. So now number 3. The limit as x approaches infinity for that. So when you're taking the limit to infinity, you can ignore all the minor values. So we're just dealing with negative x over x, which is negative 1. Check. The answer is B. Okay. Let f be the function given by f of x. What is the approximation of f of 1.5 using a tangent line? Oh, it's an easy question. First, I need my derivative. The derivative of cosine is negative sine. Plug in your pi over 2. Negative 2 times sine of pi over 2, which is negative 2 times 1. So the slope is negative 2. Okay. I need my point. F of pi over 2 equals 2 times cosine of pi over 2 plus 1. And cosine of pi over 2, as we know, is 0. So my y value is a 1. Now my tangent line. We're using point slope form, right? Y equals m, x minus x1 plus y1. Y equals negative 2. Since we're going to be approximating 1.5, I might as well plug it in already. 1.5 minus pi over 2 plus 1. Okay, don't freak out. Just take the 1.5 and convert it to a fraction. So that's 3 halves. We're going to distribute the negative 2. That's going to give us negative 3 plus pi plus 1. And we can see that our answer is pi minus 2. All right. When a particle moves in the xy plane so that the position is given by the parametric equations x and y, where k is a positive constant. The line tangent to the particle's path at the point where t is equal to 3 has a slope of 8. What's the value of 8? Of k, sorry. Okay, so we have a tangent line. The tangent line on the particle's path at 3, the slope is 8. Okay, so we're going to start by finding the slope of the tangent line. dy dx in parametric equations is dy dt divided by dx dt. So what is those derivatives? Well, the derivative for dy dt is 2kt, and the derivative of x is 1 over t plus 1. Okay, I can always clean this up by multiplying it by the reciprocal. And I'm going to leave it like this. Okay, I'm going to take this slope that I just got, and I'm going to make it equal to 8 because we were told that the slope is 8 at t is equal to 3. So 2k times 3 times 3 plus 1, which is 4. Okay, that's 6k is equal to 2 after you divide by 4. So k here is 1/3 because 2 6 is 1/3. Okay, come on, scroll down. Number 21. Okay, we got a table. Okay, I like tables because usually that means an integral. Let's see. It says, what is the average level over this 10-week period obtained using the trapezoidal approximation? Okay, so two things right here. Because they're saying what is the average level, that's telling you we have to do average value. Whenever you see anything that says average and then a blank right here, if this guy matches whatever the table is representing, like in this case level, average level, again, they're telling you to do average value. So the formula is 1 over b minus a of the integral from a to b of f of x dx. So 1 over 10 minus 0 times the integral from 0 to 10 of f of x dx. But the way we're going to do the integral is by doing a trapezoidal approximation. And the formula for a trapezoid is a plus b over 2 times h. But in this case, remember, usually our trapezoids are like slanted, right? Our trapezoids they look like this, where this is a, that's b, and this is the height. So, in other words, we're going to go ahead and take our 1 over 10, and we're going to multiply times a bunch of little trapezoids. So, a and b are your y values, right? So we have 210 plus 200 divided by 2 times the height. The height is the distance between the x values, right? This distance right here. That's 2. Plus 200 plus 190 divided by 2 times the height. And the height this time is 4. Oh, supposed to be using blue. Plus the last trapezoid, which is 190 plus 180 divided by 2 times the height of the trapezoid, which is once again 4. Okay, let's be real careful right here. 1 over 10 times 2's cancel. So that leaves us with 410 plus the 2 and this 4, they simplify to a 2. That's going to be 2 times 390. Same thing in the other trapezoid. 2 times 200, 370. All right. So this is 1 over 10 times 410 plus 800, 780 plus 600, 140, 740. All right. You take all these numbers, you add them up. 1 over 10 times. I'm going to cheat and I'm going to look at my answer. 1930, just so I don't take too long in the video. So 1,930. And then when you divide it by 10, well, we're basically just crossing off the 0. So we get 193. There you go. B. 22. The integral of this. Okay. The first thing you should do when you see a complicated looking integral is, can you simplify? We can't. Is usually substitution going to be of any help? It's not, because the derivative of negative 3x over 4 is just negative 3 over 4. It's not going to cancel out this x right here. So this is looking like it's going to be integration by parts. We're going to select the u, that is CC, to derive, and we're going to choose a dv, that is CC to integrate. So x over 2, and the derivative is 1/2 dx. So my dv is going to be e to the negative 3x over 4, and my antiderivative is e to the negative 3x over 4 times the reciprocal of the derivative times negative 4/3, right? So you can always clean that up and say it's negative 4 over 3 e to the negative 3x over 4. Okay. So now my integration by parts. Remember the acronym, it's ultraviolet voodoo. U, V minus the integral of V du. So x over 2 times negative 4 over 3 e to the negative 3x over 4 minus the integral of V times du, which is 1/2 dx. All right, let's clean this up. This is going to be negative 2x over 3 e to the negative 3x over 4 plus, if you multiply these fractions right here, that's going to be 2/3 times the integral of e to the negative 3x over 4. Okay, we just have to integrate that e. So the antiderivative is itself times the reciprocal of the derivative plus c. And when you clean this up, we get negative 8 over 9 e to the negative 3x over 4 plus c. Let's take a look at our answers here. Looks like it's B. Number 23. If we have this series, then the derivative is which of the following series? Well, first let's take the derivative. And the derivative is going to be the summation from n is equal to 1 to infinity. Remember, you take the derivative of a series the same way you do other derivatives. So we're going to bring down the exponent, and we're going to subtract 1. The denominator is just a constant, so you keep it as n factorial. So now we're going to start generating the series values, right? Plug in your 1. 2 times x to the power of 2 minus 1 divided by 1 factorial plus, okay, now plug in the 2. 4x to the power of 4 minus 1, so that's 3. 2 factorial. Plug in your 3. That's going to be 6 x to the power of 6 minus 1 divided by 3 factorial. Let's see if this is enough. 2x plus 4 divided by 2 factorial is just 2. Okay, 3 factorial is technically 6, right? Because it's 3 times 2 times 1. So that's 6, and 6 over 6 is 1. So there it is. Let's see if this is enough. 2x, so gone, gone, gone. There it is. There's your winner. Okay, number 24. If the average value of a continuous function is 12, then what is this integral? Okay, keyword here, or keywords, average value. 1 over b minus a of the integral from b to a to b of f of x dx. 1 over 4 minus negative 2 of the integral from negative 2 to 4 of f of x dx. So they're telling me the average value is 12, right? So we're going to make it equal to 12. Okay. I'm going to multiply both sides by 6. F of x dx is equal to 6072. But this is not what I want, right? We want to find... I'm good, thank you. We don't want to find just the integral from negative 2 to 4. We want to find the value of the integral from negative 2 to 4 of f of x divided by 8. So that's what we're going to do. We're going to divide by 8 or multiply by 1 over 8. And that's the integral that we want. So this right here is a 9. Okay, number 25. We're so close to finishing the first part. What is the radius of convergence for the Maclaurin series? Okay. This is chapter 10, right? Like one of the last sections that we did, and you have to know your series. So the way I approach this question, I'm not sure if it's the most effective, but the way I approached it is I took my series for 1 over 1 plus x, and I wrote it out, my expanded series, which is 1 minus x plus x squared minus x cubed plus x to the power of 4, and so on. Okay. But my job is to recreate this function. So first, I'm going to plug in an x squared everywhere I see an x. So that's 1 minus x squared plus x squared squared minus x squared cubed, and so on. And then we're going to multiply everything by 2x. So that's going to be 2x minus 2x cubed, because we're multiplying by 2x, right? So this right here is x to the power of 4. But if I multiply by 2x, it's 2x to the power of 5. This right here is x to the power of 6. But now it's going to become 2x to the power of 7. And then this one is x to the power of 8, but it becomes 2x to the power of 9, and so on. But I want to find a radius of convergence, so that means I need to figure out the summation notation of this one. So the summation notation is as n is equal to something, we have infinity, right? So we have, first of all, we have an alternating series where it's positive, negative, and so on. So we're going to say that it's negative 1 to the power of n. And you know what? We're going to start with 0. That way we create a positive. Now the 2x. Every single term has a 2x. But the exponents are changing. We have a 1, a 3, a 5, a 7, a 9. And just like I told you in class, it's just about making a linear equation, right? If we're starting with 0, your y values are 1, 3, 5, 7. So you have to figure out the slope. The slope is plus 2n, and the y-intercept is 1. So there it is. There's your series. We're not done. We want to find the radius of convergence. We got to run the ratio test. The limit as n approaches infinity of a of n plus 1. See, we're taking the absolute value. So I'm going to ignore the negative piece. So we're going to say 2x n plus 1 divided by a of n, or multiplied by the reciprocal. 2n plus 1. Okay. When you simplify this, well, the 2's cancel each other out. We're left with x to the power of 2n plus 2 plus 1, so plus 3. Well, this is pretty great because the x to the power of 2n's cancel each other out, leaving us with x cubed over x, which is just x squared. You can even take off the limit notation, x squared. So, because this is working out, the ends are gone. We're gonna set up our interval of convergence. Man, I'm running out of space here. We're gonna say the absolute value of x squared is less than 1. And if I take off the absolute value, we get x squared is less than 1. I'm not going to put the negative 1 in the back because we're going to have to square root it. That's going to be a problem. So we'll just keep the positive 1. So here we get the square root of 1, which is just 1. So here the radius of convergence, it's going to be b, 1. When you take the square root, you get positive or negative 1. Now you can put the negative 1. So you'll see that the radius is 1 in both directions. Number 26. Okay, we have a function and we have a derivative. How many values satisfy the conclusion of the mean value theorem? Okay, the mean value theorem is talking about slopes, right? It's saying that the average rate of change is going to equal to the derivative at some value c within the interval from a to b. So if I do my average rate of change, f of 2 minus f of 0 divided by 2 minus 0 is equal to my derivative, x plus 1 times cosine of pi over x. F of 2 is 1 over pi squared minus 1 over pi squared divided by 2. Well, this thankfully is just 0. Using the zero product property, we're going to split it. Okay. And now if I solve for x, I get x is equal to negative 1. But over here, we got to take cosine inverse, right? Cosine inverse of 0. When does cosine equal 0? At pi over 2, at 3 pi over 2, at 5 pi over 2, and so on. Just keep in mind that we're working for answers. We're looking for answers on an interval, right? From 0 to 2. So we got to be mindful of that. Okay. Next, divide by pi. That's going to be 1/2, 3/2, 5/2, and so on. But 5/2 is already out of the interval. So this leaves us with 3 answers. Oh, but negative 1 is also out of the interval. So now we're down to 2 answers. So 2. There are 2 values of x on the open interval from 0 to 2 that satisfy the mean value theorem. Okay, 27. This is one of those new topics in BC that we didn't cover last year, ladies and gentlemen. So make sure you know your formulas. These are the number of students in the cafeteria is modeled by the function p, and it satisfies the logistic differential equation. Okay, that's the concept. where t is time in seconds and p of 0 is equal to 25. What is the greatest rate of change? Okay, first of all, before we even started the problem, let's remind ourselves what the logistics differential equation looks like. So it's one of the versions is ky times 1 minus y divided by L. I'll tell you what L is going to be. But you can also change it, right? It just depends what you're given. You can factor out a 1 over L. And again, we talked about this in class back in chapter 7. If I factor out a 1 over L, we get ky over L times L minus y. Now think about why that works, right? Now, a logistics model, a logistics differential equation, has this general shape right here, where the maximum value here is called the limiting capacity. And that's your L. Now, halfway through the model, we have the point of inflection, which is literally t comma L divided by 2. It's halfway of the limiting capacity. And one of the concepts that we talked about is that the maximum rate happens when y double prime is equal to 0, or in other words, at the point of inflection. So, okay, let's start tackling this problem. The differential equation that was given to me looks like this one. And by matching it up, I can tell you that L is 200, which means the y value of my point of inflection is 200 divided by 2, which is 100. That's the y value for the second derivative. When the second derivative is equal to 0, the y value of my point of inflection. This is not what it's asking though, right? It's saying, what is the greatest rate of change in students per second? So you're going to go back to your differential equation, dp dt, which is 1 over 2,000 times p. P right here is the y value, right? Like if you look at the problem, it says the number of students in the cafeteria is modeled by the function p. Okay. This 100 represents a y value, which is p. So we're going to plug in the 100 times 200 minus p minus 100. And let's simplify this rate of change. dp dt is equal to 100 times 100. So just basically count the zeros. Divided by 2,000. 10,000 divided by 2,000 is equal to 5. So the maximum rate happens when the second derivative is 0, which means the limiting capacity allowed us to find the y value, which was 100. And using the 100, we can find the maximum rate here, which is 5. Okay. 28. A cube with edges of length x centimeters has a volume of x cubed. The volume is increasing at a constant rate of 40 cubic centimeters per minute. Let's take a note of that. dv dt is increasing at a rate of 40 cubic centimeters per minute. At the instant when x equals 2, what is the rate of change of x? So dx dt is question mark. X is equal to 2 centimeters. All right, that's basically it. Yeah, this is our related rates, right? So let's take the derivative of v. dv dt equals 3x squared times dx dt. Everything is increasing with respect to time. The volume here is 40 times 3 times 2 squared times dx dt. Solve for dx dt. This right here is 12. So 40 over 12. And we can reduce that by 4. So 10 over 3 is the rate of change of x. Perfect. A. 29. Oh, so close. Which of the following is a power series expansion of this? Okay, once again, one of the latest lessons that we've talked about. And you need to know your expanded series for E of x. The expanded series for E of x is 1 minus x plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the power of 4 over 4 factorial dot. Okay. We also have to create the series for e to the power of negative x. So using the series above, just substitute a negative x wherever you see an x. That's negative x plus x squared over 2 factorial, right? The negative is gone because of the square. Minus x to the power of 3 over 3 factorial. The negative stays with odd powers. Plus x to the power of 4 over 4 factorial, dot. And what we want to do is we want to add these series, because that's what's happening here. We're adding them. So e to the power of x plus e to the power of negative x is 2 plus 0 plus 2x squared over 2 factorial plus 0 plus 2x to the power of 4 over 4 factorial. And hopefully you see the pattern, because the next one's going to be 0, then it's going to be 2x to the power of 6 over 6 factorial, and so on. But now we're going to have to multiply by 1/2. So that gives us 1 plus 2x squared divided by 2 times 2 factorial plus 2x to the power of 4 divided by 2 times 4 factorial, and so on. What ends up happening here is the 2's cancel each other out. These cancel, these cancel, these cancel. And we can now select our series, which is 8. The last problem, number 30. The last problem for the first part. Which of the following statements is true about this series? Okay. The series diverges by the nth term test. Well, I don't know if that's true, so we're going to take a look. We're going to take the limit as n approaches infinity of a of n. And because we have 1 over 2 to the power of n minus n, this is 0. So according to the nth term test, this has the potential to converge. It could converge. And because it could converge, we can't say that it diverges. So B, the series diverges by the limit comparison test. For the limit comparison test, we're going to take the limit to infinity, and almost done, ladies and gentlemen. We're going to take the limit as n approaches infinity of b of n divided by a of n. B of n is the one that we're using, right, to compare it. So 1 over n divided by 1, which is to the power of n minus n, which is which simplifies to this. And from these functions, we know the numerator is growing significantly faster. So here we have infinity. This actually is the answer. Wait, it looks like it could be the answer. I'll come back to it right now. C, the series converges by the nth term test. So we already ran the nth term test, right? But the nth term test does not guarantee convergence. Doesn't guarantee convergence. convergence. So it's not C. D. The series converges by the limit comparison test for the geometric series 1 over 2 to the power of n. Oh, okay, there we go. I blanked out on something. When we do the limit comparison test, the limit has to be a constant, a positive constant. And then if that's the case, then both series do the same thing. But because we got infinity, we can't really make a conclusion. So we're going to run the limit comparison test one more time. B of n over A of n. So we have, I'm going to write it as 1 over 2 to the power of n. Actually, no. Let me keep it. 1 over 2 to the power of n divided by 1 over 2 to the power of n minus n. Multiply by the reciprocal. And because we're taking the limit to infinity, these are the dominant terms, right? Which is equal to 1. So we have a positive finite number, positive constant, which means both series do the same thing. So going back to the geometric series, since r is equal to 1/2, the series converges. And because this series converges, that means the original series converges. So it's true. So going back to option B, we ran the limit comparison test and we got it was infinity. So right there, the test was inconclusive. So the answer was D. And that concludes the first part for the 2017 practice test. See you guys in a bit.